So by this time we know what shortest job first algorithm is, what is shortest remaining time first algorithm, okay, and we have seen both of these two with in detail examples, all right. But now let's see some analysis of these two algorithms, okay. So these are the advantages and these are the disadvantages. So the first advantage is this algorithm is having much more higher throughput. Why so? Let me try to take an example, okay. Let's say you have 1 lakh rupees, okay. Now you have 11 number of loans. Now let's say among these 11, okay, 10 loans are having 10k each, okay, as outstanding, okay, and one loan, the last loan is having maybe 1 lakh rupees outstanding, okay. So now the approach one is always what you are doing, you are finishing your small loans, that is following that algorithm. First you will try to finish these 10 loans. So in 1 lakh rupees you can easily finish this 10 number of loans where each of the loans is having outstanding balance as 10k, okay, because 10k multiplied by 10, that is how much, 10 to the power 5, so that is 1 lakh. So in this approach, using this 1 lakh rupees, you have already finished 10 number of loans, okay. Let's take approach 2. Approach 2 says I will finish the loans which is having higher outstanding balance, all right. In that algorithm, what will you be doing? Using this 1 lakh rupees, you will be finishing this loan where the outstanding is itself 1 lakh rupees. So using the same amount 1 lakh rupees, now you have finished only one loan, okay. So here you finished, okay, how many, 10 loans in approach 1. In approach 2 you have finished how many loans, 1 loans, using the same amount of money, that is 1 lakh rupees, okay. So given that you have money, in this case money, and in this case, in our case, that is time. So given that in our case, when you have the limited time, okay, if you are picking those processes with least amount of burst time, you will end up finishing more processes, and that is why here the throughput is much more higher, okay. Wait time is much more lower, okay, turnaround time is much more lower. And why these two? So before I jump into explanation of these two, okay, let me convince you one more thing. So that is average completion time will also be reduced. Why so? Because always you are picking small processes. Small processes are getting finished early, and as a result new process is scheduled early, and as a result new process is also finished early, okay. So average completion time will be reduced, okay. So we know that turnaround time equal to completion time minus arrival time, okay. So in this case, if completion time reduces, arrival time is not reducing, that is constant, okay. If completion time is reducing, then this turnaround time will automatically reduce. So if your average completion time reduces, then automatically your average turnaround time will also get reduced, okay. So now let's come to why average wait time also reduces. So we know turnaround time is equal to wait time plus burst time. So wait time is how much? Turnaround time minus burst time, okay. So if your average turnaround time reduces, given that burst time is same, you cannot change burst time. If your average turnaround time reduces, automatically your average wait time will also get reduced, all right. I hope this is clear as of now. So as of now, these advantages are clear. So now let me show you some disadvantages. The first thing is starvation. So in this video, I will not be explaining in deep what starvation is. In one of the previous videos, I have already explained what starvation is. So as of now, I will be giving you very brief. Let's say there is a CPU. Okay, there are multiple small processes at time t equal to 0. These small processes have come, and by saying small process, I mean small burst time. And one more thing is, let's say time t equal to 0, one big process has come. What do I mean by the big process? I mean big burst time. Okay, let's say now your CPU has to complete all these small processes, then only your CPU can execute this big process. Let's say by the time your CPU finishes executing all these small processes, let's say one more batch of small processes have come. Now your CPU has to complete this as well. Now let's say by the time your CPU is completing this last small process, one more batch has come. Okay, let's say at time t equal to 10, all these small processes are finished. So at time t equal to 10, your CPU will get a chance to execute this big process. I mean big burst time process. So even though this process arrived at time t equal to 0, but got scheduled at time t equal to 10, it has to wait a lot. This is called starvation. Alright. So this is one of the disadvantages. So next, let me come to the biggest disadvantage. And what is that? So that is, we cannot have the burst time beforehand. Okay. Okay. We cannot have the burst time of any process beforehand. And why so? Let me try to explain. Let's say process P1 is there. When this process P1 is created, it doesn't know, okay, it does not know what is the burst time P1 will be taking. Okay, in 5 unit of time P1 will be completing, or 10 unit of time P1 will be completing. P1 doesn't know all these things. If P1 could know this thing, then P1 could tell operating system, hey operating system, I am P1, I am a process, and I have a burst time of 10 unit of time. Alright, P1, given that P1 itself does not know its burst time, P1 cannot tell its operating system what is the burst time. So as a result, your operating system does not know what is the burst time this P1 will require. So now let me break your heart. So if you go back to the old examples, if you see, we have started the problem with given burst time, alright? And in our algorithm, at every step, we kept on looking at the burst time to decide which process to get scheduled at next. Okay, so burst time is the primary factor in this algorithm. And now I told you at the very beginning, we cannot understand what is the exact burst time of any process. So there is a conflict. And what conflict is that? We started assuming that we have all the available burst times, and now I am saying you at the beginning we cannot have all the possible burst times. So then at the beginning, how did we calculate the burst times? Okay, so I will tell you the calculation strategy in the next video. As of now, just know one thing: these burst times are predicted burst times, not the exact burst times. All right, we will be seeing this prediction of burst times in the next video.